Hi, Nick. Hi, everyone who has already joined. Nick, you're on mute.
Can you hear me now?
Yes.
Perfect. Sorry, I've been managing a lot of just the last minute stuff here, and I'm getting messages, people wanting to change some things.
Yeah, definitely. Do you have an image for the background?
I can send, yeah, send by email. I've made other graphics, so I can. Do you want this one, or do you want like the
Yes,
single
please.
one? Or,
Yeah,
okay, I'll
just
send
this one.
you
That's fine.
this one.
Great. Hello, everyone.
Hi, everyone. Hi. Good you're early.
Yes, happy
Just
to
make
see
sure
everything
you can,
working well.
yeah, try that you can hear yourself, try your camera, microphones.
Of course. So how can you hear me now?
Very well.
Great. Great. So
And hi, Nihal. Hi, Michaela. Congratulations, Michaela, on your recent graduation and the achievements. And I've seen some great posts on LinkedIn recently. Right. So just double check, Nick. Do I expect an email from
Yes,
you? Or...
I just sent it.
Okay.
Let me know if it doesn't come in, because I've been flagged in the last couple
No.
of days for sending spam because of how I've sent out these invitations. So
Yes, all good. No, it should be fine. I received it. It's all good.
okay. So I had to call
Let's put
Microsoft
it
on
together.
Monday.
Yeah.
I'm not sure if they have enabled the co-hosting feature in the setting for the meeting, because I can only see make host button here. Nick, can you hear me?
Yeah, I can hear you. I just wasn't paying attention.
Okay.
Sorry, can you say again?
So yeah, I'm not sure if they have enabled co-hosting feature here because they have to do it in the setting, But
Yeah.
yeah, I'm just trying to find out about that. I can see only make host button here.
Hello, everyone.
Hello, Nihal.
How are you?
All good.
Oh, I was on mute. Hello, and good to see you all smiling and beautiful. Oh, wow, that's great.
So the screen share is working. That works.
It works for you. Maybe can you try to share the screen? Just wait a minute. No, Institute post. Oh, that's great.
Okay. Just gotta start that.
Yeah.
And can I just double check quickly, Nick?
Yeah.
So, so I start straight from the beginning, right? So Amin is not opening.
You can start from the beginning.
Okay.
The only thing that there is this agenda. So I was planning to have Eamon start and just take care of this, and then
Okay.
the sponsor.
Yeah.
But
And
then he would introduce you, and then you would
cool.
introduce the Research Council here. And basically, I divided this up to people on the right who are presenting, and then the people on the left, there are other members there. And then
Good. Yeah, that's fine. I just wasn't sure like whether he's starting. And do I pronounce correctly Ashiro name, your full name? So it's Ashiro Abidemi or something different?
It's technically it's the other way, but everyone just calls him Ishiru, the Demi
Oh,
Ishiru.
okay. So what's a
It's okay.
preferred way? Because I'm going to introduce you.
I would,
So is it Abidemi Ashiro?
yeah, that would be the best way there.
Okay,
That's
cool.
how
So
he is
you-
on the AAM Institute website. So
So you are presenting and you have a full control on present. You're gonna change slides because I don't have control on it, I believe.
okay, so I updated the slide. So if you want, the other thing is I can just run this on mine here.
That's great. All right, that's great.
Yeah.
Nick, I was wondering as well whether you can kind of change in the setting to allow others to share, because if there are some presentations to share so that it's not confusing then.
So
They
I
are
did not.
able to-
It should already be enabled.
Yeah, because I have not given you any permission and you just did share your screen.
Yeah, I just took over that manually, so that shouldn't be an issue there.
All right.
Can you guys talk? Because I don't think I can hear.
Oh no,
Sorry,
we're not.
wasn't saying
Oh.
anything there.
Oh, I can see the lips were moving. I'm thinking like, okay, so I think there's something wrong with my yeah,
I
computer.
was reading something on my screen. Great.
I like the background, Nick. That's great.
Oh yeah,
Yeah.
I better have it too because I am the host and I don't have it, Nick.
I can send you really quickly here.
Please. I know you have a lot on your table, but
I can send it because I've got it
Yeah,
now, so I
actually,
can quickly send it, Nick.
yeah, that,
So
that works.
I'll forward it.
an
And I'm going to
email.
go put on a collared shirt
Yeah,
briefly,
done.
and I will be back in a few minutes here.
All right, sounds good.
I think we're gonna get this started in 5 minutes, I believe.
6.
6, yeah. And yet I don't have my key players here.
Well, that's a thing. And I wonder where, so Amin, Amin?
Yeah, that's exactly correct.
Yeah.
So
So I'm happy to turn my camera off. And when it comes to the point of talking, then I can turn it off. Oh, sorry, turn it on.
all right, I will just be giving just a short, brief greeting, and I will hand
Okay.
it over after reviewing the agenda. Yeah, and just reading the simply reading the flyer.
Yeah. Same. And I have some brief welcome as well. So
Right. So did you share the background? Because I cannot see it on my email.
I did. Just give me a second.
And how about my voice? Is it a bit quiet or should I speak
Yes.
louder?
Yes, a bit quiet. Yes.
All right, all right.
Okay. Is it starting with VA?
What was that?
Your email starts with
Okay,
VA?
yes.
Okay.
Yeah, that's correct.
Done.
.av.
Mm-hmm.
Right.
I wonder whether we need to wait a minute or so while people just still join in, or do we start on the dot?
Our key players are joining. Great.
Hi, Amin.
Hello, hello. Good afternoon. Great to
Hello.
have you.
Hello, all of you.
Hello,
Good
we can hear you.
Hi, here's Lucas from DLR.
Hi,
Great
I
Lucas.
have still some issues with my video. I don't know.
You have 2 seconds.
Check whether the camera is locked on the top.
No, I'm. Yes.
Hello, everyone.
Hello, hello. Yes.
Hello. Hello, everyone. As you join, we just wait probably another minute or so and we'll start.
Yes, I'm just giving a few moments to. Yeah, we do have also. Once again, hello everyone. Great, and Slow is here. Good morning then. We're still giving a few moments for everyone to join.
Yeah, I have still video issues, but I maybe can fix it in the next minutes. So
You do have
already start maybe.
Take your time, no worries. Jacob, it's great to have you here.
Thank you so much. Thank you for having me.
So now it works. Perfect.
Okay. Okay. Great. Welcome, Chris.
Good morning.
Good morning. All right, we also I believe we are about to start. I would like to wait and give a few more moments for everyone else to join, but perhaps you do have your schedule, and I don't want to make it too late for you. And so, once again, thanks for joining us for first student showcase Advanced Air Mobility Institute. We are so happy having you all here.
Thank you, Amin.
So I'm just presenting our agenda here for today. So we will start with Molly, and it's a great pleasure having word from our Council of Chair, and then moving on to our Vidimir Shapiro, our Chief of Staff, and then we will have Lucas for an introduction to the reality of advanced mobility and urban air mobility here. And yes, we are having more people joining. Great, thanks for joining us. I'm just approving chat. Oh, great. Molly, could you please just have the floor for us?
Definitely, thank you so much. And my name is Alexandra Molloy, and I'm very proud to serve the Advanced Air Mobility Institute as a Research Council Chair. And more so, I'm very, very happy to welcome you to the first inaugural Research Council Student Showcase. Today, we will hear from our Research Council members and invited speakers who will present the cutting-edge research about various aspects of the advanced air mobility. And this event is incredibly important because it presents innovative approaches that proactively address the needs of the industry and also inform policy in the advanced air mobility sector. Our presenters today are on the path to propel the future of air transportation towards unprecedented heights and share the vision of tomorrow's leaders in advanced air mobility research. Indeed, the importance of advanced air mobility on a global scale cannot be overstated, and it is imperative that we embrace innovation and collaboration to address the evolving needs of our interconnected world. From enhancing urban mobility to logistics and emergency response, advanced air mobility holds the key to unlocking limitless possibilities. And before we dive into the exciting presentations, like a previous slide, I'd like to acknowledge and thank the sponsor of today's Student Showcase, Power Up America, whose unwavering support has made this event possible and not only fuel our endeavors, but also pave the way for a future where advanced air mobility becomes an integral part of the global market. Power Up America is an electric vehicle charging network that is setting the standards for various types of electric aviation, eVTOLs, EVs, etc. Power Up also focuses on the community at its core, aiming to provide customers with a convenient and reliable charging network, build robust infrastructure of charging stations to ensure that wherever you are, you can charge with ease. So we'd like to acknowledge the sponsor. I would also like to extend my deepest gratitude to our invited speakers and our Research Council members who are joining us today to share their expertise and vision for the future of advanced air mobility. And I would like to thank the team of Advanced Air Mobility Institutes and Research Council who have organized this event and make this event happen today. On this note, I'm looking forward to hearing all your amazing presentations, and I would like to pass the virtual microphone to the Advanced Air Mobility Institute Chief of Staff, Abidemi Ashiru. Thank you.
Thank you, Dr. Molloy. And ladies and gentlemen, good morning, afternoon, or evening, wherever you are today. And yeah, thank you. Thank you for joining. It is my distinct honor and privilege to welcome you all to our inaugural student showcase event. This is a gathering that marks a pivotal moment in the advancement of advanced air mobility and the future of transportation, as we all know it, right? Today, we come together to celebrate this convergence. It's a convergence of minds, the students, researchers, and industry professionals alike. We know, everybody's at the forefront of innovation within the AAM ecosystem. One thing is this showcase serves as a dynamic platform, a crucible of ideas and ingenuity, where innovative projects and groundbreaking researches take center stage. Basically, we want to ignite collaboration to drive innovation and ultimately shape the trajectory of advanced air mobility. At our institute, we firmly believe in the power of collaboration in driving innovation and obviously shaping the future. Our institute has long been dedicated to shaping advocacy and effecting meaningful change within the AAM landscape. It is a testament to our unwavering commitment that notable industry players seek to align themselves with our endeavors, recognizing the value of being connected to a community dedicated to advancing the boundaries of technology and mobility. Indeed, our institute's recent accolade as the Community Engagement Team of the Year as the prestigious eVTOL Insight AMN Awards speak volume to our collective effort in spearheading the growth and development of the AAM space. This recognition reaffirms our position as trailblazers. I mean, we are leaders who are not only shaping the discourse, but actively driving progress within this transformative industry. So today, as we gather, let us seize this opportunity to inspire and be inspired, to collaborate and innovate, to learn and to teach, and to collectively propel the AAM industry forward. Let us harness the collective power of our communities, chart new horizon, and redefine the possibility of air mobility. So I extend my heartfelt gratitude to each and every one of you for your dedication, your passion, and obviously unwavering commitment to excellence. Together, let us embark on this journey of discovery and exploration, knowing the future of AAM lies within our grasp. Thank you very much as we go through this journey. Thank you.
Thank you, everybody. We do appreciate your valuable words. So I would like to welcome Lucas Esmer. Can you hear us, Lucas?
Yeah, I'm here. Thanks. So first I want to share my screen. Hopefully it will work.
You have access. Yeah.
So maybe you can give me a short feedback if you can see my slides.
Yes.
Oh, perfect.
Yes,
so,
we can see that. Brilliant board. Thank you.
Okay, so there it is. Yeah. Yeah, first of all, thank you for this warm welcome, and thanks for having me today. Maybe I can start with some words to my person. I'm Lucas. I'm with the DLR since 2014. Started as a student, wrote my bachelor and master's thesis at the Institute of Air Transport. And yeah, since 2018, I am part of the research group of unmanned aircraft, exploring market potentials for new technologies and concepts in aviation. And in the field of urban air mobility, I'm working on the global demand estimation, system analysis, and the integration of UAM into multimodal transport systems. And yeah, I'm very glad to have this opportunity today to talk about the vision of urban air mobility and to give you some insights into the latest research in this field at the German Aerospace Center. I think urban air mobility, and today I will talk a lot about urban air mobility, but I think it's the same for advanced air mobility, has been one of the most hyped topics in recent years in the field of new technology in aviation. There has been a lot of discussions, but there are still some concerns. There are still a lot of investment in this field, and there are countless research projects which are focusing urban air mobility and advanced air mobility topics. But the vision of urban air mobility is not entirely new. Henry Ford already said in 1940, "Mark my words, a combination of airplane and motor car is coming. You may smile, but it will come." And there were also activities in the 1950s and 1960s where conventional helicopters were used for first urban transportation, but this development failed mainly due to the economic viability and the social acceptance. And now, 80 years after Henry Ford's words, and mostly driven by further technology advantages, especially in the field of electric propulsion systems and vehicle concepts, the vision of urban air mobility seems to become more and more a reality. And I think the most of you will know it, but I will summarize the whole topic of UAM with a short definition of urban air mobility by the EASA. That's the European Aviation Safety Agency, and the EASA defines UAM as follows. UAM is a safe, secure, and more sustainable air transport system for passengers and cargo in urban environments enabled by new technologies and integrated into multimodal transport systems. The transportation is performed by electric aircraft taking off and landing vertically, remotely piloted or with a pilot on board. And they further add, commercial operations in the EU cities are expected to start around 2025 with delivery of goods by drones or transport of passengers by piloted aircraft. And I also think many of you will know this. This is the Gartner Hype Cycle of emerging technologies. The Gartner Hype Cycle shows which phases of public attention in new technology goes through when it is introduced, and you can see it or you can use it to evaluate new technologies. And as I already said, seems to be a real hype topic in the past years. After some well-known publications in this field, like the Uber Elevate paper, or some publications from consulting companies. In 2019, the Gartner Hype Cycle lists flying vehicles as an innovative trigger topic. And in the years after, the news about urban air mobility multiplied, the expectations became greater and greater. And currently, I would say we can see urban air mobility in this trough of disillusionment. The picture of is slowly become clearer. We have to realize that not all expectations maybe can be achieved, but after this trough of disillusionment, innovations can come to a slope of enlightenment and will hopefully end in the plateau of productivity. And our goal at the DLR is to provide valuable contributions to better understand and design to increase this plateau of productivity in the end. And therefore, to achieve this, it's important to view from a holistic perspective. Because like any other transport system, is a complex system of systems which is characterized by components that can interact in various ways. And the changes in one individual component can influence each other component in a positive, but also in a negative way. And as a change in one component of a system can have an impact on the other components and on the behavior of the system in general, the system performance results from the interaction of all these components with an impact on all relevant stakeholders like the users, the operators, the society in general, and also on the environment. And in order to create a viable urban transport system, it is necessary to harmonize the individual system components like the vehicles, the infrastructure, and the operational framework, which, for example, includes the air traffic management for And in order to balance these interests of all relevant stakeholders, it is essential to compare the costs and the benefits when designing and evaluating this transport system. And the evaluation of benefits can include different aspects like the travel time or the travel speed, the mass efficiency, and the network capability. And the cost on the other sides maybe include the monetary costs, such as ticket prices for the users, but also the operating costs and investment costs. But they also consider external costs, which are, for example, environmental and social impacts, like the noise pollution. And I think these external costs are a very crucial point by the assessment of new transportation modes. And in the end, by minimizing the costs and maximizing the benefits, a sustainable transport system can be created that mostly meets the society's expectations and requirements. And the challenge for us is to harmonize the system elements in such a way that the transport system is accepted by the society. And therefore, the system needs to be affordable, accessible, safe, environmental friendly, and economic viable. And the DLR has been researching various aspects of UAM, UAS, and also unmanned aircraft for several years. But with the Horizon UAM project, we start the first interdisciplinary research project on urban air mobility, bringing together a lot of knowledge from different research fields to research on single topics of UAM, but also research on UAM as a system. And the Horizon UAM project combines the research about the vehicle, the infrastructure, the operations, and also the public acceptance. The main objective of the project was the assessment of opportunities and challenges for air taxis and urban air mobility concepts. And yeah, as I already mentioned, the project brings together a wide variety of DLR institutes and departments to research on the vision of urban air mobility. You can find all these institutes here on the right-hand side. And the project has a duration of 38 months and the budget of around 9 million euros. And we had also two cooperation partners, the NASA and the German aviation think tank Bauhaus Luftfahrt. And in the following, I want to give you some insights into what we did in this project, and I will focus on our 5 main work packages. I will start with the overall system simulation. This work package includes a lot of research on the operational and market development aspects, and we had here 3 main working activities. We set up a system of systems simulation framework to evaluate the complexity of an UAM system and the interaction between different subcomponents. And therefore we combine several tools we have at the DLR from different domains, like a demand tool, a vertiport tool, and the airspace management tool, and set up this simulation framework. We also developed a forecasting method to estimate the global demand and fleet size, which with a focus on different market development scenarios, and parameter studies where we evaluate the effects on ticket prices and the vertiport density on the UAM demand. And we also looked at the economic viability of UAM to estimate the operating costs and ticket fares for 3 representative UAM applications, like an intra-city use case, an airport shuttle, and in regional air transport. And when we talk about urban air mobility, we often talked about the vehicle concept and new types of vehicle concepts. And the research on UAM vehicles was also part of the Horizon UAM project, with special focus on the vehicle design, the onboard systems, and the cabin design. Here, we focus on the conceptual definition and design of vehicle configurations for 2 different UAM use cases. And what was maybe special about this design process is that the vehicle design are driven by fleet operations in these SOS simulations I described before. The selection of a certifiable system and powertrain architecture was also part of the project. We focus on sizing, modeling, and simulation of multi-rotor eVTOL propulsion systems, energy system and thermal management systems. And we want to develop a safe, comfortable, and accessible cabin concept by using a lot of design thinking methods. And we are able to build up a cabin mock-up with the virtual and mixed reality capabilities you will see later. Then we will come to the topic of safe and secure operations. And I think safe and secure operations are one of the most important elements in aviation and also for UAM operations. since vehicles are supposed to fly autonomously in the long term, we put a lot of effort into the field of safe autonomy. Here are a machine learning use case. A machine learning use case was developed for the human detectation, for example, on a vertiport. And the main issue here is how machine learning can be made certifiable. So sorry. And within the Horizon project, we also developed a DroneCast. It's a drone-to-drone communication system for collision avoidance in urban airspaces. And we worked in the field of multi-sensor navigation to design a multi-sensor navigation framework for UAM. And this includes the ground infrastructure and also onboard units for the multi-sensor navigation aspects. Then I will come to the next main work package, and here I want to start with a short sentence which I read at McKinsey, and I think this statement summarizes the topic very well. To take off, flying vehicles needs first a place to land. And so the topic about vertidromes, so that's a term we called vertiports and vertistops in the Horizon UAM project, are one of the crucial points for the UAM system. And in the project, we looked at different aspects. The vertiport design, here we did fast time simulations of vertiport airside operations for different vertiport layouts. And we also developed the vertiport airside level of service framework to evaluate the different vertiport layouts. We worked on the network management. Where we developed and evaluate different network approaches, a slot-based approach and a trajectory-based approach. The network optimization, or we worked on the network optimization under consideration of vertiport positions, available infrastructure and infrastructure capacities. And we worked on the integration of vertiports into airport environments. And here we did fast time simulation of the integration of air taxis into conventional runway systems. And we did real-time human in the loop simulations where 10 air traffic controllers should integrate 44 conventional aircrafts and 15 air taxis per hour in an airport runway system. Last but not least, we did a lot of research on public acceptance, and we're able to build up new capabilities in this field. There was a large-scale telephone survey in the German population with a question about the acceptance of civilian drones in general and air taxis in particular. The smartphone app Drone Noise has been developed to measure drone noise and assess the subject annoyance. We used this cabin mock-up I talked about earlier to do virtual reality studies on the well-being of air taxi passengers in a mixed reality air taxi simulator flying over the city of Hamburg. And we did a virtual reality study on the well-being of passers-by through the visualization of air taxis in the sky over the city of Braunschweig. And we have already, we have already been able to test some of our theoretical approaches and concepts in flight tests. And here we have excellent conditions at the DLR with the National Experimental Test Center for Unmanned Aircraft Systems in Kochstedt. It's a former commercial airport, which is now owned by the DLR, and is a test field for unmanned aircraft systems. And I think the important point here, or the important part, is that this facility is also open to external partners which want to make flight test campaigns, for example. And within this project, we want to do some flight demonstrations, and therefore we built up a modular urban city in the scale of 1 to 4, and we use smaller multicopter to representing passengers passenger carrying aircrafts. And yeah, what we want to demonstrate was an air taxi flight within the city of Hamburg. And the focus here was on the airspace integration through USpace, the vertical management, artificial intelligence for automatic detection of person, and the urban communication and navigation aspects. Yeah, this was a very fast overview of our 38 months project activities in Horizon UAM. And to summarize what we have achieved within the project, Horizon UAM has revealed the complexity of urban air mobility and the interdependencies of these system elements. We have a lot of key results here, which are listed here. I will pick some. We have established a system of system simulation framework. We have designed viable vehicle concepts. We have developed this DroneCast communication framework. We have this vertiport airside level of service. And we also built up this modular city in our test facility in Kochstedt and did first flight demonstration there. And yeah, that brings me to the main question of my presentation. Can urban air mobility become reality? And I think I can break it down a bit. For UAM to become reality, it's need to be socially accepted in a broader sense. And here acceptance includes acceptance of socio-political acceptance, the community acceptance, and also the market acceptance. And so UAM has to meet the expectations of all relevant stakeholders, such as a potential users, the industry, the governments, public institutions, and authorities. And for this, UAM needs to be designed in a way that promotes the benefits and minimizes the risks. And the results of Horizon UAM indicate that UAM could come technically feasible in the near future, but the following key challenges need to be addressed before UAM can widely implement it. And there are 3 main points. There is the profitability, and we think for the widespread adoption and acceptance by the users, manufacturers, and investors, it is essential to ensure that air taxi services are economically viable, even with low ticket prices. And these low ticket prices, we need to increase the UAM demand, for example. We have to address the complexity of the UAM system. We have to manage the complexity, and we have to fill existing knowledge gaps to remove uncertainties. And this will be necessary to achieve a high efficient UAM system. And in the end, we have to talk more about the social acceptance, and in particular, more about the community acceptance. Acceptance may be one of the critical factors in UAM implementation. And we have to address these key concerns about noise and also safety and security aspects, the high energy consumptions of the vehicle maybe, and the visual pollution and the land use. And we also have to talk about the integration of UAM into existing transport networks, to improve the efficiency of the overall transport system with the benefits for users and the society. And so we can see there is still a lot to do. And therefore, we at DLR want to continue our research in the field of UAM and also in the field of AAM, with a focus on impact assessment and the integration of UAM into multimodal transport systems. But in the end, I would say it's important that we keep in mind that we need a holistic view on urban air mobility and also on advanced air mobility. And therefore, it's necessary to bring together many stakeholders and their interests to design and evaluate the system and the system components together and find the right balance for this system. And for these reasons, events like this today, but also I would say the AAM Institute in general, are extremely important for the further development of urban air mobility. And yeah, for this reason, I would like to thank you again for this opportunity to speak here today, give some insights into our work at the DLR. And yeah, I'm looking forward to many more discussions that will hopefully follow. So thank you for your attention. And if you have any questions, please contact me or the Horizon project leader, Bianca Schuchert. We are open for any kind of questions. And I will finish my presentation with a short list of publications and preprints from our project. We are currently working on a special issue in the CEAS Aeronautical Journal, and there you will find a lot of detailed information about all the topics I talked about in the last minutes. And yeah, thank you again.
Thank you so much, Lucas. That was a fascinating presentation, and we do appreciate that. So here's a quick reminder for everyone to use our Q&A chat in case you have any question for our sponsors. We actually have an interesting question here. Any research about nuclear battery applications from Rod? Thank you, Rod, for asking.
Yeah, we have some research about the battery applications, but due to some internal reason, they came a bit later to the project. So they was only a side topic of the whole project, but we have an institute at the DLR, which is working on all these battery topics and also on life cycle maintenance questions on this vehicle topic. So if you are interested in more details, I maybe can make a contact to this our experts at the DLR.
Maybe I can add here the answer to that, Lucas, if you allow.
Yeah, sure.
Yeah. Hi from my side as well. I'm a colleague from Lucas. So at the DLR and our institute, Institute of Flight Guidance, we was also looking in the battery applications, yes, but not especially in the nuclear one. So we was looking just some lithium-ion battery mostly, but as well in different powertrain systems like a hybrid solution and fuel cell, but not unfortunately, especially nuclear battery applications for until right now, but maybe in our follow-up project.
Well, great, Neville, great. We do appreciate your participation in this question. So once again, I appreciate Lucas for that fascinating presentation. And I would like to move on to our next presenter, Neil Widmer. Niels, can you hear us?
Hi, yeah, thank you very much. Yes, I can hear you.
Thank you for joining us.
All right. Do you have the slides or should I? Oh, awesome. Thank you very much. Yeah, thank you, everyone, and also thank you, Lucas, for that very interesting presentation right now. Yeah, it's a pleasure to have the opportunity to present and speak to you all today on the exciting topic of manufacturing for advanced air mobility. So with the lightweight demands of these technologies, so fiber composite materials specifically are one of the obvious solutions that really allow us to make these technologies or use them more efficiently. However, we have to come up with new solutions that allow us to keep up with the growing demand. So we need new, reliable, high quality and the high volume manufacturing approaches. So today I want to introduce you to the work that's being done at Swinburne University in the area of advanced air mobility, and present to you some of my latest research findings in forming and automated manufacturing for composites. All right. So first, just a short background on who I am. I've studied aerospace engineering at the University of Stuttgart in Germany. And yeah, I got really excited about fiber composite materials. So I decided to focus my master's on aircraft design and composite materials. Currently, I'm in the final stages of my PhD with Swinburne University here in Melbourne, in Australia, and I focus my work on dry fiber tape materials, understanding their process characteristics for a fully automated forming and manufacturing process. Yeah, and during my studies, I had the opportunity to gain some insights into fiber composite manufacturing and testing also as a research assistant. Right, so Swinburne University is really working at the forefront of advanced air mobility in Australia. The Aerostructures Innovation Hub is a major project that looks into the developments, design, and manufacturing of air vehicles and drones, and is actively collaborating with many SMEs in Australia and large corporations like Boeing. The Air Hub under Adriano Di Pietro is now aiming for a major new initiative in the field of advanced air mobility to set up a corporate research center to really accelerate this industry-driven research. And I'm sure Adriano will present more on this initiative at the upcoming AAM Summit at the Gold Coast here in Australia as well. Swinburne further has an industry scale lab in which I as well performed all my experimental work during my PhD, which allows us to directly verify our approaches on an industry scale. So this includes like a 16 laying head automated tape placement machine for composite manufacturing, a double diaphragm forming station for forming, ultrasonic trimming, inspection, and a consolidation press at the end. The whole thing is combined with a robot, so we can really demonstrate automated manufacturing capabilities. Right, so coming to my research, I'm looking at two different aspects of the just mentioned production process, focusing on dry fiber tapes. These really allow us to combine the advantages of a fast layup and forming process. So first I'm looking at ultrasonic spot welding, which is a process that you can see in the video right now. So we use it to combine individual tapes layers together to create a connected preform that we can then not manually, automatically like move between individual production steps. So yeah, this is ideal for high volume manufacturing, as it will be required for advanced air mobility, hopefully in the future, and many other industries. Right, so I study those weld spots to ensure that we don't damage our fibers and that our tapes really stick together as we want them to be. The second part of my research, I'm looking at a forming of those two-dimensional shapes into three-dimensional geometries, because, well, rarely we have really just two-dimensional parts, right? Here I actively build up knowledge through like material characterization to better understand the forming behavior of these tape materials. And this process can then be used to enhance the forming quality at the end. Right, so just a quick look into the work that I'm currently doing, or one of the latest research findings, looking into automated forming of a rib structure, as you can find it in a typical aerospace application. So this geometry here is lightly like loosely based on a Boeing rib geometry. It just made a bit more like slightly more challenging through the introduction of some more convex and concave radii. The idea was to make it as challenging as possible while still being close to a realistic part shape. So this part kind of stands representative, its part shape stands kind of representative for every curved geometry that you can imagine in advanced air mobility vehicles like eVTOLs or drones. Right, so here I was able to prove that we can successfully form a complex geometry from these 2D near-net shape layups into a 3-dimensional geometry, making use of forming processes and automation processes that really enable us to use, like, to minimize material scrap while keeping cycle times low at the end, and also obviously the achievable quality as high as possible. The results of those findings will now be set in conjunction with the material characterization data to help us predict and optimize forming results for other geometries that can come up in the future. So this is really an important step in future high volume manufacturing applications, especially, for example, for advanced air mobility sectors. So keeping it short today, this was really just a short introduction into the capabilities at Swinburne and our research into high volume manufacturing of fiber composite parts and some of my latest research results. We've proven that we can produce parts and of a high quality and repeatability. And as we move forward now, we're looking to include more and more aspects of a modern manufacturing process that includes like full traceability, part tracking, modeling approaches, and more like that, which is currently on the way as well. So thank you for your attention. And if you're interested, feel free to reach out or get in touch now or later. And I'm open to any questions and discussions. Thank you.
Thank you so much, Niels. At least myself, I had the highest advantage from your insightful presentation. We do appreciate your insightful presentation here. So I would like to welcome again our newcomers and give a warm welcome to our next presenter, Sayed Mujahid. Sayed, can you hear us?
Yeah, I'm audible to you.
Great. Yeah, yes, we can hear you. You have the floor.
So I'm Sayed Mujahid, a final semester student of aeronautical engineering at Global Academy of Technology, Bangalore, India. Interned as an aircraft design intern at Mallard Enterprises, USA, and the Youth Ambassador and Research Council member at Advanced Mobility Institute. Skills include aircraft design, CAD, and eVTOL design. So like a short intro of mine. And next I'll go to my research work. So the problem statement is like in the road ambulance, there are many factors that delay the ambulance to carry a patient to the nearby hospital. The factors are like traffic related and weather related. Many things where the ambulance are getting delayed to carry a patient to a nearby hospital. So there is a need of an air ambulance to carry a patient to transfer from the accident place or like such and to the hospital. So as eVTOL technology advances, integrating air ambulance becomes crucial for rapid hospital access. My research focus on designing an efficient cabin layout for air ambulance within the framework of evolving air mobility. So the outline will be like optimizing interior layout of patient comfort and medical equipment accessibility, investigation technologies, and patient care during the transport. So after some research, in the autonomous aircraft, we have divided into two sections. Like in autonomous aircraft, the 1.5 meters front will be for the avionics and the battery system, and the remaining 3 meters should be for the patient equipments and the patient stretcher seat, paramedics seat, and everything needed for an air ambulance. So The next will be like, as to brief out, the summary will be like, I have designed a backdoor design to match fuselage shape with a high tolerance, door strategically positioned for easy cabin access, level floor design for convenient movement, modular stretcher system, presence of aeromedical equipment as meeting the ambulance requirement, advanced screen display and defibrillator strategically placed for quick access in emergency, fuselage divided into front and back compartments. Front compartment includes, as said earlier, and LED lights for focusing the patient, and the air condition system for comfortable cabin environment. Cabinets equipped with hydraulic door mechanism for easy operation, ample storage space for medical supplies and equipment, paramedic seat with side-by-side movement and 360-degree rotation for easy access for equipments and the patient care, and the skin for infection control and hygiene maintenance. I'll show you next slide. Like this is an overall 3D model of the air ambulance design. So it is exterior design, and this is an interior where you can look like the LED lights are placed over the roof. And this is a stretcher placed inside the cabin, and the ECG monitor display, and the defibrillators and the cabinets for aeromedical equipments to be placed there. And in front of the stretcher there is a seat, paramedic seat for easy access. So after all the research work, like it is a summary of the research work where we have done equipments like everything needed for an air ambulance. So this is an efficient air ambulance cabin to integrate for any eVTOL aircraft which has 3 meters cabin space. So that's about the research work. Thank you.
Great. So yeah, well, we enjoyed so much your fascinating presentation. So I would like to give a warm welcome to our next presenter. Slide, please, Lucas. And great. So I would like to welcome Priya O'Sullivan, our medical delivery insight. So can you hear us?
Yes. Hi, everyone. Can you hear me okay?
On the floor.
Thank you. So hello, everyone, and thank you. I'm excited to be here today to talk about my PhD research on medical delivery drones in sub-Saharan Africa, and honored to be a part of AAMI's first annual student showcase. I'm going to just turn my camera off for the rest of the presentation because my computer is running a bit slowly, but I'll turn it on again at the end if there's any questions. So as I mentioned, my name is Brie O'Sullivan. I'm a third-year PhD candidate at Western University in Canada. I come from a background in public health, and more specifically global health systems, which is the main perspective that I use when approaching drones for good or drones for health. I'm also a policy analyst on the World Health Organization team at the Public Health Agency of Canada. And in my free time, I'm also a drone research consultant. I've worked with multiple drone operators and organizations here in Canada, designing research studies on their programs. And I also work as a STEM education consultant, designing drone-related workshops for students in primary and high school. Now, before I dive into my research, I'll first briefly explain just what a medical delivery drone actually is, because I know that we have people here from all different aspects of the drone community, not just the niche of public health drones. So a medical delivery drone, as it sounds, is a specialized drone which is designed to transport medical products, including vaccines, medicines, blood products, AEDs, and even donor organs, which is something we're still experimenting with, but have had a couple successful trials. These drones are typically fitted with features like temperature controls in the cargo holding area, including cold chain at temperatures around -80 degrees Celsius. And they come in different shapes and sizes to meet specific needs and goals. So for example, the drone on the left here is a fixed wing drone by Zipline, and the drone on the right is a multi-rotor drone by the company Drone Delivery Canada. And in my area of work, we're mainly focusing on the applications of this technology to remote, hard to access communities, though there are definitely urban applications as well. So this is a map from the Medical Delivery Drone Database, or MD3, by the group UpDog. This is a really cool interactive database of all the medical drone projects happening across the world. I'd recommend checking it out if you're interested. The details are at the bottom left of this screen. So as you can see from this map, Africa is a main incubator of medical delivery drone technology and holds most of the world's long-term successful drone delivery systems. Unfortunately, most projects globally don't get past the initial trials or pilot projects. And this is an amazing example of the continent of Africa leading the way in technological innovation. So my PhD research aims to understand the barriers, facilitators, and processes of achieving long-term sustainable drone delivery systems, particularly within low-resource settings. As I'm sure a lot of people here can imagine, these systems are a lot more complex than just having more flexible airspace regulations. So my research will include 3 very detailed case study analyses on thriving medical delivery drone systems in sub-Saharan Africa, which we'll look at more closely in a moment. These case studies will then be compared to one another to draw high-level recommendations and considerations for organizations hoping to begin pilot projects in other areas of the world, including in places like Northern Canada. So I purposely chose 3 cases here that are very unique from each other, despite all being located in sub-Saharan Africa. These projects have unique political, geographic, economic, and social contexts, differently structured companies in terms of for-profit versus nonprofit, and different sources of funding as well. So the first case is located in the very small East African country of Rwanda, which also has a very impressive health system. I'm sure if anyone knows about medical delivery drones, they've heard about this one, this company and project. So the company Zipline has been working in Rwanda since about 2016, and they've worked with the Rwandan government to create an incredibly successful, fully integrated and national scale drone delivery system that serves over 8 million people in rural Rwanda. They have an average of 2,000 drone deliveries every month with an average payload of 1.5 kilograms and an average flight distance of 100 kilometers. The main products transported by Zipline drones are blood products. However, they also transport routine and emergency vaccines and medications. This project has ample funding, including from the government of Rwanda, as well as many well-known nonprofits such as Gavi, the UPS Foundation, and the Gates Foundation as well. The next case is located in the Democratic Republic of the Congo, or DRC, which is a very large Central African country, which experiences significant political instability and poverty. This, of course, will pose very unique challenges and requires different processes compared to other countries, even though they're in the same region, like Rwanda. Despite this, the organization Village Reach and their partners in and out of the DRC have successfully implemented a provincial-scale medical drone delivery system in Equateur province and are currently expanding their operations to other provinces as well. There are currently an average of 75 drone deliveries per month with an average payload of about 1 kilogram and average flight distance of 48 kilometers. These drones are mainly carrying immunization products, lab samples, and medications for diseases like tuberculosis and HIV. The main partners of Village Reach for this project include Swoop Aero, which is a drone manufacturer and operator, and the local Ministry of Health, though this project doesn't have any internal funding yet. Their main funders are Gavi and the Gates Foundation. And finally, the third case is located in the island nation of Madagascar, located about 400 miles off the southeastern coast of the African continent. Despite being an island, Madagascar is a very, very large country with the challenging road infrastructure and features a lot of extremely isolated communities. So this drone program, which is run by the organization Population Services International and the local drone manufacturer and operators Aerialmetric, is currently working in 2 regions in eastern Madagascar with about 100 deliveries per month, a larger average payload than the other 2 cases of about 2.8 kilograms and flight distance of 70 kilometers. These drones are mainly carrying routine and emergency vaccinations, as well as malaria testing kits and treatments and other essential medicines. Funding for this project is also external and comes from organizations like USAID and the Global Fund. Now, I hope this is going to work. I uploaded some videos, but it looks like they might not have transferred over. Okay, maybe I'll just send those to Nick later and he can distribute them. I actually just got back from Madagascar this weekend, where I met with my partners and received ethics approval from the Ministry of Health there for my research. I took a few videos while I was there of the drones in action that I thought I'd show to everyone because it's very exciting to see these drones in action, but it looks like they're not going to work. But maybe we can fix that later. Oh. Yeah, it looks like they're just images. Sorry about that. So what is next? So I'm currently starting my PhD data collection this year, and we'll be running interviews virtually in the DRC this summer. And I'll also be back in Madagascar and Rwanda this fall for 5 weeks in each country. And that is it for me. If there's any questions, I think we have some time, but please correct me if I'm wrong. I also left my email here as well as a QR code for my LinkedIn if anyone wants to chat more later. Thank you to our hosts as well for inviting me to speak.
It's so great having you here, Bree. That was a fantastic presentation, provoking presentation on medical delivery. So let's move on to our next student leader, Nabil Hagag, presenting insights on flight guidance. Nabil, can you hear us?
Yes, thank you.
Here.
So I'm sharing as well my screen. Just give me a short hint. Can you see my screen?
Yes, yes.
Perfect. So thank you, first of all, for the invitation for today to speak. So my name is Nabil Hagag. I'm a colleague as well from Lukas Asmar from the DLR, German Aerospace Center, especially from the Institute of Flight Guidance. And my topic is about the mission-based flight guidance for advanced air mobility, to consider as well the energy demand or especially the energy consumption. I want just to roughly show you a short introduction into the topic. How can urban air mobility ensure safe and reliable flight operations? And we need always to consider one main party around here, and that is the contingency procedures, meaning the Plan B. Plan B incorporates emergency situations, holding procedures, alternative routes, diversions as well, or landing sites. And the main key point around in here is the backbone of the eVTOL, especially the powertrain. And so the aim of the research is to calculate the realistic energy demand for eVTOL, especially in dynamic urban scenarios, that meaning to consider as well maneuvers and maybe other factors, but as well to calculate or to recommend minimum energy reserves, considering these non-nominal scenarios or contingency procedures. My focus of the PhD topic is especially on urban air mobility. I know we can divide up advanced air mobility into urban and regional. So I classified up to 100 kilometer. My focus as well, especially more on VTOLs, not an SCTOL or CTOL. And propulsion types are really bright. So I consider battery, but as well fuel cell and hybrid solutions. And for European version, we are looking into the certification limits of the SC VTOL by the EASA. And I just want to roughly show you a few concrete results out of the last presentation what I have done at the ICNS last month. And as I mentioned, we are looking into eVTOL aircrafts, and especially during this presentation, I want to show you the results of one focus of an operational range about 100 kilometer with a multicopter, especially a quadcopter as a configuration. We can calculate the energy demand based on the state of the art what is already published for helicopters, for example. I don't want to deep dive in each of the equations, but I want just to roughly show you their necessary equations to calculate the energy demand. So in this calculation, I was considering lithium-ion battery with a specific energy density of around 250 watt-hour per kilogram. And based on the energy capacity, you can check as well your cell, or consider your cell discharge rate. If we're calculating energy demand, we need to consider two different modes or phases. One is the energy demand during hover, and one is the energy demand during cruise. Later on, if you have questions about the equations, we can discuss them. But more interesting is the urban air mobility concept of operation. And I mainly use the basic out of the CESAR project in Europe here, the COLX UAM. That was a project with different stakeholders as well, like Volocopter, where the demonstration of use-based services and solutions which could support the UAM flight operations. And if you had a look into that picture, the focus here is Germany and UK. So this picture on the right side, you can see the flight plan from Frankfurt Airport to the city center. Based on that, I calculated especially the energy demand. For the regulatory framework, as you may know from a European side, EASA, we have several frameworks like the MOC SC VTOL or the NPA 2022-06 or the opinion number from March 2023. But in all of these frameworks, there are no regulation existing yet into minimum energy reserves for eVTOLs or considering contingency procedures. As well, like a little bit more globally, by the GAMA, the General Aviation Manufacturers Association, they published a paper about managing range and endurance of battery electric aircrafts, and they showing, if we deep diving into that, that we need, however, a reserve energy during our flight. And they showing as well that the power demand during hovering and landing is the most intensive party. And based on all of these information, we try to connect all the information together in a simulation, what Lucas as well mentioned. And one of that is the path planning. So we have internally a program where we can optimize based on energy efficient or time efficient and energy consumption of flight planning, based on as well moving obstacles. And these simulation is in-house, and we can set up globally all cities worldwide, because physical energy demands are basic everywhere. And just to roughly show you how the conceptual design and process to calculate these energy demand is a little bit complex, but I try to sum it up very simple. So obviously we need to look in the ConOps definition, we need to check the vehicle requirement analysis, but as well to consider safety analysis based on that certification, what is published. And to size that vehicle internally based on another institute at the DLR. And out of that, we get a vehicle concept as a characteristics. And these data, we will design a flight mission with constraints, and all the obstacles, we can extract that based on GIS, checking a scenario. The use case here especially was Frankfurt, and out of that we get a data input, the vehicle rotor speed, and by of that we can calculate the energy demand, especially. And obviously with the energy demand we can calculate as well the emissions after that for other institutes which can be interesting. For this use case especially, I showed you, I want to show you some key results. And for this use case, the condition is to fly from the Frankfurt airport to the city center, what is roughly around 15-17 kilometers, with 4 passengers and a flight altitude about 150 meters, which is roughly about 500 feet. No headwind speed, no or optimal air temperature at flight altitude, with 30 seconds of hovering for starting and landing. And to consider as well safety buffer to each of the buildings, roughly in total 50 meters, but we considered based on these 50 meters obstacle buffer, navigation accuracy, but also wind effects. And we considered as well in our simulations all the minimum height of buildings about 100 meters, or all relevant buildings in the area. Before, in the few slides before, I was showing the selected vehicle, what we can size and design, and this is a real scale vehicle, what we calculated, as you can see here, as a maximum takeoff weight about nearly 2 tons, and a battery weight about over 700 kg for 4 passengers, as a quadcopter concept with a battery capacity or a battery energy capacity more than 150 kilowatt hour. Yeah, I just showed you that picture from the scenario, and we calculated different scenarios for the nominal flight, that is as a reference, that is mostly clear, but we want to check what is on off nominal. So we need to check no-fly zones as well. So that's why we need to fly around these no-fly zones, or moving obstacle like the blue circle around in here with the safety distance to the helicopter, for example, like the target vertiport, but what happens if the target vertiport cannot reach out because of any reason, and to define as well alternative vertiports, as you can see here on the other side of the river. And these yellow lines is the SID or star for conventional aircrafts, and that's why we need to fly from the airport terminal into the direction of the east and then into the north. So that's why we cannot fly directly to our target vertiport. And as I promised, I want to show you some key results because that is very, very important. In this base, especially a calculation, we come out as a result that climb phase is obviously consuming more and a little bit more energy than the descent phase. And each kilometer consume, and depending on your cruise mode, between 2 and 3 kilowatt hour. And just a quick stop roughly for the eVTOL consume 1 kilowatt hour, and each hovering of the vehicle about 1 minute consume more than 3.6 kilowatt hour, which is obviously a little bit more than the cruise. And these factors, we need to consider them for our missions to have a safe and reliable UAM operation. What are the limitations in our calculations? Environmental factors are not considered, but it will be follow up. So like wind or air temperature, which has a huge impact into that. But as well, the vehicle parameters we just designed them and calculated them, but we need to have an empirical validation to have a real test scenario and calculate that based on that. But I think the most of the eVTOL manufacturers will not give us an air taxi so easily to test it, even when we have the test facility in Kochstedt in Germany. And obviously for the battery model, we need a deeper validation, especially on the cell aging and ambient temperature. To coming up to a conclusion, specific energy density and powertrain efficiency are crucial factors for path planning for eVTOLs. And the outlook, as I mentioned, these three factors, the environmental issue, or the impact of state of health and battery temperature, has a huge impact into the range of our operational range, but as well new battery technologies like lithium air battery or the nuclear battery was just mentioned in the chat, but as well to deep diving more into an energy efficient path planning algorithm to calculate as well other vehicle configurations, not just the multicopter, but as well to consider lift and cruise model or tilt wing or tilt rotor vehicles, but as well other powertrain systems configurations like the serial hybrid, parallel hybrid, fuel cell, and different configuration as a powertrain. What is the backbone of that? And obviously different flight mission profiles with different altitudes, etc. Yeah, thank you for your attention, and feel free to contact me if you have more questions. And I just showing up here my email address to send me an email.
Thank you so much, Nabil. We do appreciate that. With a big thank you to Nabil for providing us with a delegated presentation on flight guidance, I believe. Now let's delve deeper with Christopher Conrad. He will take the stage to present on collaborative UTM, a key aspect actually of advanced air mobility. Christopher?
Excellent, thank you very much. I'm not sure if someone could share the slides or if I shall share them myself. Let me know what's best.
Yes, if I believe if Nick has access.
Excellent.
Okay, great. So I believe,
Here we are.
Could you please present?
Yes, of course. Can you hear me well like this?
Yeah.
Perfect. So, once again, good afternoon and thank you for the invitation. I'm Christopher Conrad and I'm just starting my PhD at Cranfield University after having finished my master's in advanced air mobility there. And today I shall be giving a very brief overview of my PhD research on collaborative decision-making for UTM, which is also being carried out in collaboration with Safir Ready, which is an EU-wide project that seeks to achieve mission readiness for medical drone deliveries here in Europe, amongst other critical applications. So to start off with a very brief introduction, as we've been hearing, UAS and AM operations are really poised to revolutionize the aviation industry. And in fact, we're seeing an ever-increasing profile of civil, commercial, and recreational applications for these new technologies. Now, to cater for this increase in demand, it's almost inevitable that there need to be new traffic management solutions. And in fact, we've seen several global, let's call them proposals, pop up. Now, what's quite interesting is that amongst all these proposals, there seems to be, let's say, consensus that a federated ecosystem is the way forward. And such a federated approach does indeed offer several advantages, especially when it comes to innovation and competition, but also brings about a number of unique challenges, especially when it comes to coordinating the various actors that are involved. So with this context in mind, the research aims to investigate and explore dynamic and non-binary prioritization schemes as an effective way for resilient and collaborative decision-making within this federated UTM ecosystem. So the research first starts by developing a distributed but integrated decision-making framework, which essentially involves a unique decision-making model per actor, as obviously is needed within this federated ecosystem, but also combines these decision-making models within a common framework, which essentially incentivizes and facilitates cooperation and communication amongst these various stakeholders. It then builds on this to develop and deploy procedural and, more interestingly, intelligent prioritization schemes that help resolve any conflicts that arise within this decision-making architecture. So such conflicts could be strategic, when, for example, multiple missions are trying to book a resource in advance, such as a portion of the airspace, a vertiport resource, or so on and so forth. But they could also be tactical, when you detect a potential collision amongst multiple aircraft and have to determine who has priority, so who has right of way and who will likely need to incur additional delays to avoid the higher priority vehicle. Now, this problem brings about several unique and interesting challenges, so some of which are, how can on-demand business models be fairly introduced within, or rather in parallel with existing pre-scheduled models? How can these systems be made resilient, first of all, to malicious actors, which might be trying to provide false information to guarantee that their missions are continually prioritized, but also to any unavailable or unsynchronized data, which is a scenario that is quite likely to happen as the number of actors continue to increase. It also becomes quite interesting to see how to accurately reflect the, let's call it, intrinsic urgency of different mission applications, especially when you're dealing with medical deliveries, defibrillator deliveries, so on and so forth. And it's also a very, let's call it, interesting challenge, how to balance, or rather navigate, the various objectives of different actors. And here we're not only speaking about different actors which have different objectives, but also when a single actor has multiple possibly competing objectives. So for example, a UAS operator or a UTM service provider might want to simultaneously try maximize sustainability, maximize social impact, and maximize fairness and equity, and minimize delays, so on and so forth, all of which are obviously secondary to safety. So with such algorithms, we will look into on how such actors can dynamically select which prioritization scheme to choose to, let's call it, achieve the optimal trade-off amongst these various objectives. So with this in mind, the research has already developed and prototyped an initial distributed and integrated decision-making architecture through a number of collaborations with various industrial partners here in Europe, and we are currently in the process of refining it to better reflect the industrial reality of the UTM industry. We have also quite comprehensively simulated this decision-making architecture, which has already given us some very interesting insights on how decisions taken by a single actor will influence and will trickle through the entire, let's call it, global UTM ecosystem. And obviously all these results will now be published in the upcoming weeks and months, and also pave the way very nicely to start developing, deploying, and evaluating these prioritization and conflict resolution schemes. So once again, thank you for your attention, and please do feel free to reach out for any collaboration or further questions you might have. Thanks.
That was fantastic. Thank you. Thank you so much for helping me to be timely manner. And so I would like to invite Noah Lee, elaborating on fan noise prediction. Noah, do you have access? Can you hear us? I believe no, can you hear it? Can you hear us, Noe?
Yes, sorry, I just went to bathroom.
Great having you here. You have the floor now.
All right, should I share my slides?
Yes. Can you see our screen? Can you see the presentation?
No, I see my face. Oh, I can see now. Yeah, thanks.
Great.
So hi, my name is Noah Lee from Boston University. I am a PhD student here, and my research is focused on unsteady aerodynamics and aeroacoustics. And I'll make a very short presentation about some of my current research and recent projects in our group. And can we go to the next slide? Yeah, so my project is focused on turbofan engine, the most common type of engine in modern airliners. And it is also similar to the electric ducted fan engine, like what Whisper Aero uses, which is quite different from many other UAM applications like Joby, which use open rotor. So the turbofan has many moving parts, and so does it produce many components of aerodynamic noise. I highlighted some of the components here. The orange text here are the core stage noise that only exist in a traditional turbofan, and the blues are the fan stage noise that exists in both traditional turbofan and electric ducted fan. And in the modern high bypass ratio engines and the electric ducted fan engine, the fan stage noise and the fan exit guideway interaction noise is the dominant source. And this part of noise is due to the interaction between the turbulent fan wake and the fan exit guideway, which also called the stator, a component that is used to improve aerodynamic performance. And this is what I am currently focused on. And why do we care about noise? Well, obviously it has large impact on human mental and physical health, and the FAA has regulations on how much noise can be emitted from an aircraft. And these regulations are expected to be become more stricter in the future urban air mobility. And now back to the research. Simulations plays a very important role in aircraft engine design, and noise, which we can be seen as unsteady pressure, can be solved by a Navier-Stokes solver like large eddy simulation or particle collision and streaming method like lattice-Boltzmann method. And these methods are very expensive and takes up to millions of CPU hours. And low fidelity methods still plays a very important role in design optimization. And the particular model that I use is a semi-analytical method that is based on what we call the cascade model. And it is coupled to a low fidelity computational fluid dynamic simulation. And it's considered less complex in physics, but it can be completed in less than 100 hours. And it's very suitable for optimization and extracting trends. And some of my recent work includes a trend study of broadband interaction noise based on factors like tip clearance, mass flow rates, and fan speeds. In another recent publication, we presented a hybrid approach by coupling a machine learning neural network model into a semi-analytical acoustic model to predict the interaction noise. And some of my other works that are more under development are modeling the effect of non-uniform inflow and the effect of wing placement, which will be presenting very soon in the Aeroacoustic Conference in June. And some other work includes fin stage CFD simulation. And I am I am part of the aesthetic fluid dynamics and acoustic lab at Boston University, and the work I highlighted was sponsored by the FAA Ascent project, and our group also does research in multi-fidelity simulation in urban air mobility noise and eVTOL performance that is funded by NASA ULI. This is a separate project, and we also work on exploring the roles of cavitation as a raindrop breakup mechanism during the hypersonic flight. And for more information, you're welcome to visit our website or scan the QR code for more recent publications and research. Thank you.
Thank you, Neil, for the presentation. So everyone, let's take a break, quick break for 10 minutes, and we will get back for our next presentations after that. And feel free to use our Q&A from and to ask your questions from our presenters. And we will be back after 10 minutes. Thank you. Hello again, everyone. So I'm just giving a few moments for everyone to come back from the break.
Hi. Yes.
Welcome, welcome. Thank you for joining us.
Am I supposed to share the screen or we already have the slides?
We're actually just going to go to Brie O'Sullivan first, who will talk over her videos, and then we'll get into your presentation.
All right.
Amin, over to you here.
Great everyone for coming back. And I would like to present our sponsor once again. Power of America is an electric vehicle charging network that is setting the standard for EVs and eVTOLs and all other forms of electric aviation. The goal is to provide us with a convenient and reliable charging network that is community-centered. And also the work is to build a robust infrastructure for charging systems to ensure that wherever you are, you can charge and with ease. Thank you. So, okay, I would like to welcome Aziz on board. And can you hear us?
Yes.
Great. Thank you for joining us. So you have the floor.
Thank you, but I don't think this.
We're just going to go to Brie first. She's going to talk over her videos here, and then
Yes.
we can get into it.
Oh yes, thank you, Brie, for getting the video ready. Okay, I've been waiting for it. So yes, we were missing videos from our presentation from the very board Sylvian had for us, and so we are presenting the video again now.
Thank you. Sorry, everyone, for jumping back in. We got the videos working. So these are two videos that I took during my recent trip in Madagascar. This is on the eastern coast in a place called Tamatave. And this is an example of the delivery drones in action. So this is a fixed wing drone that also uses vertical takeoff and landing. So you'll see it take off in just a moment. This drone is carrying routine immunizations destined for a remote village about 50 kilometers away. And then the next one is just a clip of it using its horizontal flight to go off. So that's it. I just wanted to share these. They were supposed to be in the presentation, but we had some technical issues. So thank you, Nick, for making that work. And I'll disappear again.
It's great. That was brilliant. Thank you so much for taking your time because it was difficult probably during this session to get it ready back. Awesome. So we have Mohammed again on board. Great. You have the floor.
Thank you so much. So good afternoon, everyone. My name is Muhammad Azizuddin Imtiaz. You can simply call me Aziz. I'm currently a research assistant at the Department of Mechanical and Aerospace Engineering at the Indian Institute of Technology, Hyderabad. And I'm also pursuing my MTech by research. So my key research areas are aeromechanics, which is an amalgamation of aerodynamics and flight mechanics, computational mechanics, as well as shock loading of solids. So I've been doing research in the last 6 years, and in these 6 years, I have delivered key research and development projects for prestigious government and private organizations in India. So coming to my work, so I worked on India's first fully autonomous passenger eVTOL. So this eVTOL that you see in the center, the CAD model, is the one that we had made. This project started in 2019 and concluded just last year. And as you can see, it is a multi-rotor configuration with 16 rotors. And it is also a modular design where you can actually detach the cabin or any other payload. So my role in this project was leading the aerodynamics and flight mechanics, as well as assisting the system integration and the flight testing of the vehicle. And during this project, yeah, you can see the animation on the bottom right. So this animation is basically showing the velocity field, high fidelity simulation of the velocity field in a quadcopter, right? So you can see that the vortex sheet which is generated due to the rotation of the propeller interacts with the vortex sheet of the adjacent propeller. So the obvious question that arose was, what should be the distance between the two adjacent propellers so that these interactions can be minimized? So and also, what can be the effect of these interactions on the performance of the overall performance of the vehicle? So my MTech thesis was titled "A Study of These Aerodynamic Interactions Between the Adjacent Propellers." So on the left-hand side, you can see a figure, which is basically a schematic of what I just said. So there is a vortex sheet which is generated by each propeller, and there are very strong tip vortices attached to each propeller, and these tip vortices interact with each other. So now the distance d, which I have mentioned here, what should be that distance such that we are able to minimize these interactions? So there are two methods to analyze this. One is doing a CFD simulation. Doing a CFD simulation would be very computationally intensive and also expensive. And so we decided that we will go for an experiment. So I designed this experiment, which you can see the schematic on the right-hand side. So we have two propellers, which are attached to an electric brushless DC motor. And we are controlling these two motors with the help of an Arduino. The Arduino is programmed to give an accurate pulse width modulation signal so that the speeds are controlled accurately. And below that, we have a mount and a biaxial load sensor, which can sense both thrust as well as torque. So we are also powering it with an SMPS, because if we use a battery, there are chances that the voltage may drop during the operation. And if the voltage drops, the RPM may change. So that is the reason we are using a switched mode power supply to maintain a constant voltage throughout the experiment. So the key data that we are acquiring is the thrust, the torque, as well as the RPM. And these two mounts that I have here, they are movable so that we can change the distance between these two. The key performance parameters in rotary wing aerodynamics, one of the key performance parameters is the figure of merit. So this figure of merit is actually the ratio of the ideal power which we get from the momentum theory, to the actual power that we are giving as an input. And we do it by using non-dimensional parameters, where this CT is the coefficient of thrust and CP is the coefficient of power. CP and CQ are coefficient of power and coefficient of torque respectively. So what we are measuring is the figure of merit of the system as we change the horizontal distance between these two propellers. So that was the entire schematic of the experiment. The process is still in place actually. The initial results suggest that if I consider the diameter of the rotor as d, so if the distance between the adjacent tips if it is more than 0.1 times the diameter, then the interaction is quite minimum. And if it is less than 0.1 times the diameter, then we see some effects due to the interaction on the performance. We observed some effect we compared it with a single propeller and two propellers. Then the result that we obtained was, when we are using two adjacent propellers, the figure of merit actually drops by about 4%. And that essentially means we are supposed to provide 4% additional power to get the same thrust output. So the question is, where does this power actually go? So there are multiple reasons. There can be noise, there can be aerodynamic losses. So these are the key reasons. Another thing that we are investigating is the signal data, the data that we have. We have very high quality data, and we are actually running the time series analysis and the frequency analysis for the same. That is still in progress. So this is the overall snapshot of the work that I am currently doing as a part of my thesis. So if you have any questions or if you want to have some chat with me, you can always contact me on my LinkedIn or my email. Thank you.
Thank you, Aziz. We do have a couple of minutes. If you have any questions, please feel free to ask your questions from our presenters. Okay, seems we don't have any questions. So thank you, Aziz, once again from your presentation. And now we move on. I would like to welcome Nihal Tuzkan, discussing, describing, elaborating the importance and impact of urban air mobility, noise and impacts.
Thank you. Yes, I am Nihal Tezcan. I'm studying Sustainable Air Transport Operation and Planning at University of Salford. And today I'm going to present about preference of urban air mobility in Manchester, recognizing noise impact. Yeah. Yes. One of the significant concern with urban air mobility is the noise impact compared to traditional transportation systems like buses, trams, and trains. UAM vehicles, especially eVTOLs, have a different noise profile. While they may produce less noise, overall, the frequency and type of noise can be more noticeable. About the environmental impact of urban air mobility, this impact extends beyond just operational emission. The life cycle analysis of lithium batteries used in eVTOLs shows that their usage and production and disposal contribute significantly to the overall environmental footprints. The supply chain involved in producing these batteries significantly influences the achievement of sustainability goals. By comparing the carbon footprint of urban air mobility to other modes of transport system, we can assess its sustainability. It's essential to consider all these factors to ensure urban air mobility is a truly green alternative. And now, Vertical Aerospace is a leading British company in the advanced air mobility sector, known for its innovative eVTOL designs. Founded in 2016, the company has made significant strides in developing efficient and sustainable solutions in urban air mobility. This company achievement includes successful test flights and securing partnership with major industry players. Comparing their progress with global competitors highlights their position and contribution to the urban air mobility industry. And during this research, I will talk about a multimodal transport system which combines various modes of transportation to create a seamless and efficient network, integrating urban air mobility with existing transport options such as buses, trams, and trains in Manchester can enhance connectivity and reduce travel time. During this research, to understand the noise impact of different type of transportation system, we will conduct noise measurement at several key locations in Manchester, like Piccadilly Station, Victoria Station, and National Express bus station, especially Manchester Barton Aerodrome. By using standard methodology, we will gather data to compare the noise level of urban air mobility vehicles, these preliminary results will help us to guide noise mitigation strategy and community engagement efforts. Thank you so much, everyone.
Thank you, Nihal. It's indeed a great pleasure having someone from Salford University, and thank you for your presentation. So I would like to welcome aboard our next presenter, Ottavio Pedretti, presenting infrastructure for urban air mobility. Ottavio, can you hear us?
Yes, hello to everyone. Can you hear me?
Yes, I can hear you clearly. Thank you for joining us today. You have the floor.
Thank you as well. I share my present. Okay, I'm trying to share the presentation, but seems okay. Hello to everyone. I'm Ottavio Pedretti, a licensed architect in Italy, and I'm a PhD candidate at Politecnico di Milano in the architecture department. In particular, today I'm going to share with you my research on the infrastructure, on the land infrastructure for the urban air mobility. And basically my research is structured as the presentation of today, where I will give you a frame of the research, and I will briefly explain all the chapter of the research. In particular, my research is funded by the Next Generation funding from the European Union, and in Italy by the National Recovery and Resilience Plan, through the activity of the National Center for the Sustainable Mobility. In particular, my research is framed into the activity of the Air Mobility Spoke on the sustainable design and social acceptance. And as far as I understood, my PhD research is the first of its kind in the architecture field, and this is a really challenge for me, and it's also the interesting part. But I have some questions inside my research on why and what is the link between the urban air mobility that is mainly explored under an engineering point of view and a management of the operation, and why we need to explore also under an architecture point of view. So, and what are the implications in the vertiport network inside the urban environment, and especially in the Italian context, where the city are quite full and packed, and how can architectural strategies can be sustainable, integrate into the urban mobility discourse and in the vertiport in particular, and when will Italy embrace the paradigm shift and prioritize the flexibility of architecture according to the future needs of UM? And to explore the research, I use different methodologies that is linked to the interview, because for me, the papers and the materials is more related to the engineering part that is fundamental for the research, but I need also some insight from the key opinion leaders of the sector, and I conduct several interviews to understand how different players move around the topic of the vertiport. The reading of existing vertiport, of course, they are only projects, but for me are fundamental to understand the direction that they took. I'm doing some exploration through the utilization of AI generated image to try to figure out future scenarios. I'm building some case study to apply the project of a vertiport network in the Italy area, and in particular to the Gulf of Napoli. But in order, with the companion, I'm building up the literary review of the papers related to the engineering part, try to extract what are the main elements that are important under the infrastructure point of view, to understand the link between architecture and the mechanical part. And on the other side, I'm exploring what is the imaginary of the previous century inside the field. Like in the 30s, we have a lot of imagination of how the airplane can land inside the city, but of course wasn't feasible due to the technological limitation. But nowadays we can start to dream again, you know. And at the same time, as I told, I'm start to redraw all the vertiport that I found online from the render. I try to understand the relation between the plan, the landing space, to understand how a vertiport is built, and to arrive to define different design strategies to integrate the vertiport inside the city, and to understand how vertiport can activate different procedure in the city to improve the quality of the space, to regenerate abandoned areas, to use the interstitial space of the city, and also in relation to the discourse of the intermodality of the urban air mobility with other public transportation system. And in particular, the case study is focused on the Napoli area in Italy. For the research, Napoli is an important point due its geographical configuration. Napoli is in the south of Italy. Italy is one of the biggest cities, and here we have a relation between the city and the internal area of the island that actually are very low infrastructured. And we have a lot of limitation to the geographical condition, and the traditional infrastructure have a high cost and the long delivery times. So the scenarios that I'm building up is related, the first step about the emergency, to use vertiport and urban mobility to deal with emergency. The second part is related to the delivery of parcel, and the last scenarios is related to the passengers procedure, like for touristic purpose. And so in the research, the steps is to define the theory, to improve the design strategies, and to explore the case studies, and to try to apply these strategies to really to a real context. Thank you so much for your attention. And if you have any question, you can contact me through the website. Thank you.
Thank you so much, both of you. We enjoy your presentation. That was brilliant work. So I would like to welcome our next presenter on board, Mrs. Gala. Michaela, can you hear us? Great to have you here. Great to have you here. You have the floor.
Okay. Thank you. Okay, here we go. All right. Hello, my name is Michaela Galler, and I'm a high school senior. I actually graduate next week, which is exciting. And I'm also a member of the Advanced Air Mobility Institute's Youth Council. And I wanted to thank you so much for letting me be able to speak today. I am the captain of the United States national drone soccer team. And last May, under the coaching of Kyle Sanders and Robert Ferguson, our team went to South Korea and secured 3rd place in the world. This past April at the academic drone soccer World Cup in San Diego, we ended up achieving 2nd place, again with the help of Robert Ferguson and our new coach, Miss Melissa Garcia. We once again faced an amazing South Korean team, and although we still have much to learn from them. We are starting to catch up. Coach Cho from the South Korean team has been an exceptional mentor to us, enhancing our competitiveness, which even when facing his own team, he prioritizes us for the enjoyment of the game and the advancement of STEM, which has made a significant difference for us. Go. So drone soccer is an exciting new sport that combines the strategy and teamwork of traditional soccer with the thrill of flying drones. Imagine the high-flying excitement of Harry Potter's Quidditch, but instead of riding broomsticks, players control drones. The game is played inside a fairly large arena, which isn't like a giant cage, and that keeps the drones from flying away and keeps the players on the outside to keep them safe in case a drone goes flying. So ensuring that everyone ends up staying in like one place. Okay. So the drones, which come in 2 different sizes currently, is the 20 centimeters for middle school and high school players, resembling a traditional soccer ball, while the 40 centimeter is for college players and more for adults, are about the size of a beach ball that are flying in a much larger arena and are quite faster than the 20 centimeter drones. Let's see. Get the video to start for y'all. There we go. Okay, so as this video plays, in a drone soccer game, each match or each team has up to 10 people, but however, only 5 players are active at the time when flying in the tournament. Each student is controlling their own drone, and the other team members assist during the repairing sessions and charging batteries and reprogramming the drones as needed, because that is very important for the sport. The drones are protected by a sturdy cage to handle the inevitable mid-air collisions, which are very frequent because that is when the main part of this sport. It's kind of like drone combat in a way. The main goal is to fly the striker drone through the other opponent's goal, which hangs in the air like a Quidditch hoop. The goals are suspended about 3 meters from the ground, making the scoring a real challenge. The game is very fast-paced, with each round only lasting 3 minutes. Just like in Quidditch, where players have different roles like chasers, beaters, and seekers, drone soccer players have specific roles as well. In drone soccer, each of the 5 players on the team that are flying has a specific role similar to positions in traditional sports. And the positions are the striker, the primary attacker responsible for scoring goals by steering the drone through the opponent's goal. The forward assists the striker by clearing the path and distributing the opponent's defense to make it easier for the striker to score. The libero acts as a defensive player, protecting the team's goal and blocking the opponent's guide and striker. And sweeper, another defensive player who helps protect the goal by intercepting or blocking opponents' drones, while the keeper is the main defender of the goal, positioned very close to the goal to block the opponent's striker from scoring. Each position plays an important role for both offense and defense strategies, contributing to the team's overall performance in the game. Between rounds, there is a 5-minute break. During this time, the teams rush to repair any damage to their drones, replacing batteries, and plan their next moves. This break is crucial because quick and effective repairs can make a very large difference between winning and losing. It is a high-pressure situation, much like a pit stop in a NASCAR race where every second counts. That is why having designated students within the team that has the 10 students, they have designated students like reprogramming, building, while the other teams or other students are participating in the flying portion. Now, drone soccer is not only an exciting game to watch and play, but is also highly educational. It encouraged teamwork and collaboration by combining the thrill of competition with the principles of STEM learning. Drone soccer provides a unique engagement experience that teaches valuable skills. I can go back real quick to the quick. Oh, here we go. Pilot Prodigies. Using Drone Soccer as a platform, I established my company, Pilot Prodigies, to bring a hands-on STEM experience directly into the classroom. As a private pilot and a professional drone pilot, I've developed a program specifically designed to help underserved middle school and high school students to explore their interest in STEM and aviation through drone soccer. Our presenters, who are high school and college students that are either pilots or drone pilots, but also engineers and other different degree programs within aviation, explore their interest in STEM and aviation through drone soccer. Our presenters, having someone of similar age has really proven to be an inspiring way to show that starting at a young age is possible. With a program that offers workshops and drone demonstrations through mentors are really great for resources, because from my age, I'm only 18, but when I was a little bit younger, I really looked up to people that were around my age. So having someone that is around my age is really cool to have, because I'm trying to think of a good word for it, but I know a good mentor. But thank you so much for having me and letting me share a little bit about drone soccer with all of y'all. And if you have any questions for me, please feel free to contact me on LinkedIn.
What a great presentation. Thank you, Michaela. We are actually indeed surprised in today by witnessing our ambassadors, YOS ambassadors' presentations. It was great to see all of you here, our ambassadors, doing a great work, advocating advanced air mobility through this vast community. So I would like to, for the next person, I would like to welcome on board Kyla Gray, elaborating on one of the most significant activities within our missions and dignity within our institute, multi-stakeholder initiatives in advanced air mobility. So Kyla Gray, you have the floor.
Thank you so much. I'm very excited to be here. My name is Kayla Gray. I just finished my Juris Doctorate program at the University of Oklahoma, and with the emphasis in international comparative law. And the thing about the law is, just as this feels kind of like just the cutting edge and we're creating new things, the law tends to catch up only after the technology has been created. And so the reason why I'm here is because we have the ability to kind of research and kind of be on the front end to make sure that everything's set up, or there's guardrails in place. Because this is a new technology, because this is kind of a new way for transportation, I know we're all excited about the possibilities and the good and the great and all the ways that people's lives can be changed for the better. Unfortunately, with new technology, there's both the good and the bad. In the same way that the internet has created so much good across the world, there's a lot of negative effects of the internet as well. And unfortunately, I'm coming in from this situation of this is exciting and this is wonderful, but there are ways that we can tailor our businesses and the way that we conduct ourselves to protect people. So and I don't want to do it, but if you can think for about a few seconds about the potential negative effects of this new AAM industry, such as the right to life, and by the right of life of protecting people, for privacy, for the risk of forced labor or human trafficking, or for sexual trafficking. These are some of the negative potential effects of this new industry. But the really great thing is that we're thinking about this now. And that leads into the next, which should be the next slide, I don't know if you have that. Yeah, and then one more. Yes, so multi-stakeholder initiatives are kind of a way to combat these things. And so they're different stakeholders addressing different issues. So if you look at the bottom of the thing, there's the Global Network Initiative and the EITI. The Global Network Initiative was created for companies that produce the internet and other such things, to create a kind of a fence around it for privacy. And this is in the case of the Yahoo case in 2000, where we don't have to go into it, but there were severe human rights violations because the companies did not have a person on board, or they didn't have a clear way to handle requests from the government that could violate people's human rights. And then the Global Network Initiative was created kind of on the back end of that. The EITI is for the extractives industry, for both different things, and well, at that point, like diamonds. But there's over, let's see, in 2017, there were 445 different initiatives that regulated 9,000 different companies. And so in this way, we get the ability to be on the forefront to create an MSI, which would kind of marry both companies, nonprofit organizations, and other organizations that will create a situation where we can protect human rights moving forward. But the beauty of this is that we're creating the Autonomous Transportation Public Trust Initiative. And that is so wonderful that a lot of the times MSIs happen on the back end after something bad has happened, but we get to kind of create this at the beginning and weave the protection of human rights with companies at the beginning. And by bringing them in and them on to create this ability where we're not going to be reactive. We get to be really proactive in this space. Dan has really been the leader in this, kind of pushing this forward, so to make sure that we are really including everybody. So yeah, so that's where we're creating. We're in the process of having it looked over by certain academics to make sure it's an MSI that will work and that will include people. And I think it'll be launching this summer. But this is the newest MSI on the block, and we're going to be able to really create a collaboration. Now, sometimes governments are involved in MSIs, sometimes they're not. Right now, we're not having governments kind of baked in, simply because sometimes governments happen to be human rights violators instead of really protecting the common good. So yeah, that's kind of the main thing today, and I'm just grateful to be here. If you have any questions, please reach out to me or send me a direct message, and we'll go forward from that. So thank you so much for your time.
Thank you, Carla, for your time joining us today. And so I would like to jump and welcome Peter on board. Peter, can you hear us?
Yes, I can hear you.
Welcome on board. Yes, you are.
Hello everybody. My name is Peter. I am currently a master's student in Linköping University in Sweden, doing my aeronautical engineering degree. And today I'll be presenting my master thesis topic, which is for the methodology for planning and integration of a US-based package delivery system in rural regions, which is also part of a bigger logistics project called REGWAS in Germany. Together with my external supervisor, Dr. Georgiev. Yes, so this is the logo of the project, and for the agenda today, I'll quickly go to introduce AM and thesis topic. I will provide further context through explaining what the REGWAS project is. I'll go through some challenges and the motivation for the thesis and the project, and we'll go briefly through the thesis parts, primarily the preliminary mission evaluation tool and some initial results from it. So, as we all know, in the past decade, drone technologies, parts, components have become more widely accessible, available, affordable, and thus have allowed for many actors to provide opportunities such as disaster management, emergency responses, surveillance, logistics, agriculture, and some of the more notable ones being Zipline and Wingcopter, which provide services such as medical supply delivery in remote regions. For the thesis itself is twofold. It's on one side developing a scenario for a US-based delivery system in a rural region, and together with that, on the other hand, is the methodology, developing and proposing a methodology for planning and integration, and of course evaluation of such operations. Next, the RegWAS project, a little bit more information about it. It's based in Bebra, the municipality of Bebra in central Germany. It is for the delivering of a novel regional logistics system, which also involve drones, which complement the general logistic processes, and to investigate how such local supply can be optimized by implementing such a system. Excuse me. And one other aspects which for why this region was chosen was because the elderly population is increasing, as in many places in Europe, especially the rural regions, and to see how the attractiveness can be raised for such municipality by implementing a novel concept. So the current logistics model, as in many places, is companies or courier companies, they have local distribution centers, they deliver their packages to them, and then from them distribute them to their customers for last mile delivery. However, in such remote regions, it can be often the case that a single vehicle delivers only a singular package, which in many cases is not really the most efficient use of resources. And of course, environmentally is not the most sustainable. So the RegWAS project tries to deliver a new system, to propose a system where a regional distribution center is placed in Bebra, and it collects all the packages from various companies and producers, and consolidates them into a singular municipal system, which then more efficiently tries to use its resources to distribute it to local distribution centers, which are located in the villages nearby, and which then are distributed separately. Either customers come to pick them up, or volunteers or employees pick up the package to deliver it to the last customer. And of course, it also uses drones for high value added goods, such as medical supplies or equipment. And now briefly, I'll just go through the how the regional distribution center and the local distribution center are planned to look like. The regional distribution center is located in a shopping center in the center of the city, Bebra. This is a horizontal view. It will house maintenance facilities, loading and unloading areas for both ground and air. On the roof, it will house the vertiport, which is a flat roof, so it will be able to support and house the infrastructure. This so in the beginning, it will be able to. It's planned to conduct the loading and unloading of the drones manually. However, in the future, it is planned to upgrade it to an autonomous system, an automatic one, to be able to increase efficiency and, of course, response time. So the local distribution center, it's the first one is located in Zolz. It's located in a shop, which is also a bakery, and it has a parking lot where the vertiport will be located. It will serve both package storage and also it will serve the drone maintenance and storage, and it will also allow for ordering and receiving of packages. So the vertical slice of the flight geography, this is a hilly region, so a flight system could benefit because it needs to fly primarily in a straight line, while the roads need to go around the hills. and the altitudes were chosen in response to relevant legislation. The horizontal flight geography, as you can see, the majority of it is primarily in a straight line. It takes into account natural reserves, buildings, villages, important infrastructure, and the red dots are emergency landing spots, which are take into account dense vegetation or buildings nearby. So the challenges and motivation for the project and the thesis are, of course, we need more sustainable means of transportation, and to get more data about the feasibility and sustainability of such operations in rural regions, especially in Europe. And by sustainability, we mean like the three pillars of it, which are environmental, social, and economy. And also another motivation or challenge, let's say, is the regulatory processes, which can be quite strict and tedious, again, especially in Europe. And this can lead to frustration when trying to apply for such a operation, especially when it's beyond visual line of sight. And of course, the motivation is to develop some easy methodology, easy to follow at least methodology, an example for such, which takes into account the various technical, social, and risk factors as well. So the thesis parts, as mentioned, are the rigorous context, theory, and methods surveys, both public and expert surveys, the development of a concept of operation document, which describes the operation, a risk assessment, which is part of this CONOPS, and the estimation model, which I'll go into quickly in a little bit, and the flight tests and validation. So from relevant literature, it was discovered that public acceptance plays a huge role into the sustainability, long-term sustainability of operation, since it can impact people's lives. And especially the ground risk is quite important, since people, I mean, obviously do not want to be in danger of such operations. So both surveys, both public and experts, will be conducted in order to gauge how much the population in Germany and in the region, how well does it respond to such operations. Then the CONOPS, also inspired by relevant literature, has been, will try to answer important questions, such as what is the current situation and motivation, what is the, who are the direct and indirect stakeholders, what are their responsibilities, how does the operation perform, what systems does it include, how do they work, what risks are, what are the perceived risks, and how are we planning to mitigate them, and of course providing some measures of performance to gauge how the operation performs. So now for the preliminary mission evaluation tool, the idea behind it is to have a means for various actors, be it institutions who want to do such operations or some company, to be able to gauge how, and at least have an initial estimate of how the mission will perform, how much energy does it consume, what kind of sustainability can be expected from it. And of course, this will help with initial risk assessment. Currently, the tool takes into account only the vertical portions of the flight, which are climb, level flight, descent, and of course, if needed, also a hovering segment. It basically takes into account various inputs such as atmospheric variables, headwind, air density, mission parameters such as distance, and drone specifications from aerodynamics to the number of rotors, and so on. Then it takes it into a loop, which depending on the configuration, and it computes for different parameters. And primarily, it's a function which is basically it's a function which calculates the power required for each segment and then the overall energy required for the mission. this is the drone which is going to be used for it. It's a medium-sized drone at around 10 kilos without the payload. It can carry up to 9 kilograms of payload, and but the planned payload for the thesis and the project is not more than 2 kilograms. And now I'll go through several results, initial results. And currently, if this is shows the relationship between the range and the energy required. And orange line shows the energy capacity of the battery. So at 15 meters per second airspeed with 2 kilograms, the drone will be able to fly at around 16 to 17 kilometers. And the distance between Bebra and Zolz is at around 8. This is the energy, the relation between the airspeed and the UAV required energy. On the left side is the total one. On the right side is per kilometer. The unit used is kilowatt hours per kilometer. And so far, it seems that at a higher speed, the drone requires less energy per kilometer. This is the payload mass. As expected, if we increase the payload carried, obviously it will require more energy. And if there is no headwind included, as in this plots, this means that it means that it can fulfill a one-way trip with even 9 kilograms of maximum payload if a case requires it, for example, an emergency. So this shows a relationship with the headwind. And if the headwind goes above 8 meters per second, the drone will not be able to fulfill its even a one-way trip, which this means that the headwind should be monitored quite effectively during operations. And of course, as we need to have an estimation of the greenhouse gas emissions, taking into account the average emissions from electricity production in Germany, which are around 0.5 kilograms of CO2 per kilowatt. It goes to show that for a single package, the drone produces quite a low amount of CO2 compared to a diesel vehicle. And what is next is, of course, since it takes into account aerodynamic coefficients, the model itself, this currently it uses a placeholder once, let's say it like that, taken from the literature. However, further literature review needs to be conducted in order to be able to have better, to have more accurate estimations of what the aerodynamic coefficients are, since many companies do not provide data, or they might not have it at all for their drones. And of course, a more complete life cycle analysis for greenhouse gases, which, for example, can take into account the CO2 or greenhouse gases when producing a battery for a drone, and of course, comparing to other modes of transportation. And of course, lastly, the flight tests and validation of the tool itself. So this is for me, and if you have any questions or comments, and thank you, of course, for having me.
Thank you, Peter, for your time. I personally went through a couple of questions myself, but the thing which was common for myself was, how do we recognize contingency plans? Because in your operation plan, which was a type of hub and spoke in your logistic using multi-model, so you presented a segment design for your operation, and then you went through energy analysis for different segments. And how do we fit in contingency plans within these energy analysis or our operations? Contingency, well, emergency, or yes.
Well, if I understand your question correctly, well, for example, the energy required if it can be implemented into a UTM system, for example, it will be able to tell, okay, taking into account the headwind, taking into account the payload, and all the parameters that can be controlled by the operator. If it requires more energy, then, or if it requires, for example, the drone at the end of the run will have less than 20% of energy, then maybe the flight will not be conducted, just to keep it on the safe side, because weather conditions can change. So this is one contingency. And also, for example, other contingencies can be supplying with different systems, such as a parachute, for example, can be a good solution, or something similar. I hope I have an answer that's answered your question.
That was helpful. I appreciate that. I appreciate your time. Thank you. Thank you.
Thank you.
And great to have you here. So I would like to move on to our next presenter, Julia Rachel, Career Advisor.
Good afternoon. Good
Thank you.
afternoon. Yeah. Can you hear me?
Yes, great. You have the floor.
Fantastic. Thank you. Right. Going through the whole rigmarole of sharing my screen, which of course, having stared at this now all afternoon, I can't figure out how to do. Bear with me. Here we are. Okay. Thank you very much for having me. Let me start with that. Whilst we get ourselves organized, a little bit about me, and then let me move this away. There we go. I work for a company called Mercury Oval. We are a global leadership development and search and selection company. My personal background is aviation, and my job here is to work with clients and with leaders and talent in aviation and aerospace. And obviously, advanced aero mobility is a big topic for me and my team here. So whilst we cover all of these different elements of the aerospace and aviation sector, you can see there in the bottom row, AAM is something we call specifically out. And in fact, we formally launch later on this week. So to give everybody a little bit of context on what we do, I mentioned that we're in leadership development and search and selection, but what that means is we actually go back right to the business strategy of a company. So may that be an eVTOL manufacturer, may that be a vertiport operator, may that be an airport or an airline who are considering new technologies. We go back to the business strategy, we establish a capability framework, and then we go and look for the right leader or talent to fill that role successfully. What I wanted to do was kind of take my 25 years of experience in aviation and aerospace and overlay this with what I'm witnessing in the eVTOL sector to help all of you sort of set a context of the kind of sector you're going into. So let me start with what I've put here on the left. So on the left, I have the traditional setup of an aviation business. And on the right, I have the emerging sector of the eVTOL business. And of course, on the left, we have legacy businesses which need to pivot. Yeah, they need to change. They are, the old polluting, possibly losing their social license to operate. And it was talked about earlier in Peter's presentation about the stakeholder engagement and the social acceptance. So the airlines are under pressure. The eVTOL businesses are modern startups with very different dynamic leadership styles who are inherently sustainability driven. So my generation to your generation, there is a gap. And the eVTOL business is really rather symbolic of that. When we look inside the companies, the airlines, the traditional aerospace businesses, they need to re-engineer their processes, their ways of working, because they're quite hierarchical and have very traditional complex business models and complex stakeholders around them who are also hierarchical and legacy driven. Whereas when we look at the eVTOL business models, much flatter structures, very much speak up cultures, simple business models, still very complex stakeholders, as we heard earlier, but I would imagine much faster moving. We can't move fast on licensing and airworthiness, not possible. But by and large, we see fast progress being made for things that in the traditional aerospace and aviation sectors would take a very, very long time. Clearly, the use cases are very different, and the size of the platforms are very different. That make a very different business model. But when we sort of look at this, you know, like for like, this is my observation. Last but not least, what I am observing is that diversity, equality, and inclusion in the traditional businesses are very much initiatives. Again, it's this pivot. Yeah, we can't. When I did my pilot training 25 years ago, I would have been one of less than 100 women pilots in a community of 3,500 in the company I was doing my training with. That number has skyrocketed in the time since then. So diversity, equality, and inclusion was an initiative, but in the businesses you guys will operate in, they are inherent. Inclusive culture is at the center of the eVTOL business model, not so much for political correctness sake, but because the idea that if we take people from different backgrounds, from different thinking patterns, from different educational backgrounds, from different ethical backgrounds, that the road to innovation, the curve, is much more accelerated. Before I joined NU, I ran my own company called Avensis, and we did purely electrification and battery work. And we partnered with a company called the Faraday Institute in the UK. And we did some research. And so we talked to hundreds and hundreds of PhD, battery-related PhD candidates and graduates to find out what they struggled with in their careers. And they told us, over 75%, told us that they really struggled in their first and second proper appointments post-grad with the lack of business and with the lack of soft and business skills. And that is what I wanted to focus on today. And of course, here we are. So you guys are all in masters and PhD programs, and you know better than I do your technical skills. Yeah, you might be aiming to be a battery scientist or an engineer of some description. Maybe you're training to be in AI, simulation, airworthiness, law. Maybe you want to become a pilot. Those skills are captured in the capability frameworks of your future employers. And if you don't meet that basic criteria, you won't get an interview. But what a potential employer will definitely want to screen for and look for and talk to you about are the additional skills. And what are those additional skills? Well, Mercury will break this down into roughly this set. So we have teamwork, emotional intelligence, stakeholder management, effective communication, team leadership, project management, creativity and problem solving, time management, agility, adaptability, and fearlessness. Now, let me break that down for you a little bit. We talk about teamwork, but how do we define teamwork? What are the facets of teamwork? Teamwork is conflict resolution, it's mediation, accountability, collaboration, anything that allows you to operate and let your team thrive. In terms of self-awareness, emotional intelligence, we're looking for self-awareness, for the ability to empathize with your colleague, social skills, motivation, etc. Then we have the communication skills, again, much talked about. What is excellent communication? Active listening, verbal communication, written communication, non-verbal communication, yeah, so your cues that you give, presentation skills, and especially for very highly educated and technical people, lifting your communication from the detail that you're used to operating in your lab and in your research. Lifting that to business level is a real core skill that we identified straight out of our research to be something that when PhD students nail that, they do really well in their first and second job. And then the last two I wanted to touch on was creativity, because you're thinking, well, I'm an eVTOL, why would I want to be creative? We're not talking about painting and drawing and modeling. We're talking about creative thinking. So how do you solve problems? Can you brainstorm with your team? Yeah, can you do experiments? And can you then afterwards analyze the results? So that's what we call creativity. And then the last one, the adaptability, the agility, and the fearlessness. You are in a sector that is fast growing, you're pushing boundaries all the time. So any of you who are in tech will know the term fail fast, learn fast. So resilience, flexibility, a growth mindset, and reframing failure to just having had a go and trying something new. Last but not least, with a little bit of time we have left, I wanted to send you on your way with a couple of tips around interviews. First and foremost, when you go and meet a potential employer, really do your research on the people you're meeting, know their career path. We're in a digital age, everything is transparent, so really make sure you know who you're meeting. Prepare for competency-based interviewing. You will be asked, especially as you're entering your career, you will be asked competency-based questions for the things, the skills I've just listed. So describe a time when you worked effectively in a team, when you had to really push your communication skills. So write yourself little answers, little case studies, be ready for those kind of answers, questions, because when you're not prepped for this, they can be quite overwhelming, because you will not be asked, are you a good communicator? Because the answer would obviously be yes. You will be asked, tell me about a time when you used that and what the outcome was. Take notes during the interview, yeah? Always have your pen. Show the people you're talking with that you're taking notes, that you're serious about this. Breathe and take time. I never do, and I always teach. So breathe and take time. Move on to the business level, yeah? So ask questions about the business plan. Ask what your role is contributing to this great goal of the company. Every company has a vision, a mission, and a value statement. So make sure that you let the interviewer know that you're aware of that, but you want to know what you're doing to contribute to that big goal. And then don't be fearful of closing out the interview. So with closing out, we mean ask what will happen next. What are the next steps? Is anything missing from my application? Do you need anything from me right now? Ask if there are any reservations to moving forward with your application. So it might be a bit of a push for you, but you will stay in control of that conversation. And it's really important, because if they have reservations, or if they feel, oh, you know, we're not clear on this or that, it gives them an opportunity to revisit you with you straight away. And then the last tip is to really send an enforcing email, a piece of communication when you're finished, a day later or that evening, to say, I really enjoyed meeting with you. I really feel I would fit well, and I would really enjoy contributing to your company. That would be my top tips. And I believe we have a minute or two for questions or a discussion, but over to our moderator.
Thank you for your time, Julia. Yes, indeed, we do have time if you have any questions, everyone.
Everybody's happy to go and get a job.
Oh, yes.
Brilliant.
Hello, do you hear me?
I can hear you, Joe.
Okay, this is Joe. Hello. I'm in the business of employing people, so normally this tips that you gave is very important, because normally when they are nervous, they don't give themselves 100%. So they don't know what to say, they don't know what to, what I can say is the questions that you said they are going to ask, they are real. It's exactly what we ask. So exactly what we need to know, and we need to put you to the test, and we need some kind of, we don't want perfect questions, perfect answers. We want strongness on the people, on the person. So we need to feel that this is going to be the guy that will help me do this and that. So for who's listening, this tip slide, I photographed it, I'm sorry. but it's something
I'll
that
send
is it's very important, and you need to read. You need, if the question is very difficult, read 2 times and then answer. You don't need to show your emotions, not emotions. The emotions are good, but you don't need to show stress. So I hope this presentation will help you a lot. So lack of experience sometimes is a problem, but this can be solved. You need to show that you will be the guy to solve all the problems that you can. I'm sorry.
I couldn't echo that more, Joe, because now that I have left the core aviation world and I'm in leadership advisory, it's quite interesting that we're flipping. So you spend about, after 5 to 15 years in your career, it's all about the track record, right? What has this person achieved? How, what have they contributed? And then when you move into leadership, and you will know this yourself, it becomes about the capabilities again. What is this person capable of? We can see that they can do clients and stakeholders and close deals and run products and build production lines. We know all of that. But now we're interested in what they're capable of when we push them into leadership, when we push them to go and help us run a startup, secure funding. How will they go about that? So, thank you for that input, Joe.
Yes, that was a great insight, actually. And I was thinking about this, that, there has to be always a space environment to improve in order to prove and to take advantage, that was what I've been seeing and witnessing within the, young community struggling to find a job. Because yes, as you said, there is no proven track because they haven't had the space to improve, to prove. So it's always great, yes, having brilliant people trying to help these young ambassadors or young people to, actually, let's say, create the environment for acceleration.
Yeah, absolutely. And the better you can present yourself in an interview, to be confident, and again, not cocky, but confident, right? So where is that fine line? Then yes, and that's why that piece around asking questions, how do I contribute to the overall goal of the business? It shows maturity. It shows that you're thinking about, not just about the tech that you're excited about, but you're actually thinking about, the purpose of the company, and that will set you apart from the next 10 candidates.
Of course, such as finding the gaps to add the value to the company and the team with filling the gaps. And yes, of course, it all takes, I do, summarize it with luck. I say it's where the preparation meet the opportunity. So I am lucky. So that's where we can fill the gap. Of course, if you are excited and passionate to add value in order to prove something.
Absolutely.
I have something else. I'm sorry. Regarding the normally when I was interviewed, I had 2 rules. First rule was I have to do my work, my homework. I'm sorry, I'm a little bit tired. So I need to understand all about the company. If I'm interviewing something that doesn't know what he's saying or going to enter, it's impossible to continue the interview. And the second question I normally do in the end is I ask the person that's interviewing me if she likes to work in that company. This is something that is very, very good to connect and also to understand, because I'm going to do a change in my life. I really want to know your opinion. Also, that's a very good question. And that's it. I'm sorry, I'm taking too much time.
No, we are having enough time for this discussion, and I believe this is the session for Student Showcase, and of course, helpful as it is, this type of collaboration is essential. I believe so. Julia, you have anything to add?
No, just I have to say I'm really blown away by some of the sessions I listened to today, you know, from design to soccer. What else was there? The use cases, the different use cases. So I spent a lot of time talking to Vertiport and eVTOL stakeholders, and there's an ongoing discussion on, well, you know, will it ever happen? But of course, the use cases most people think about are passenger and airline driven. So I was with a big manufacturer 2 weeks ago, and their use cases are entirely driven around serving humanity, emergency responses, medical supplies, that kind of thing. So I'm really excited about what this next generation is thinking about. So well done, everyone.
Of course, we are striving to serve generation. We call it Jetson or Alpha, in order to some people call it elevating civilization from type 0 to type 1. So that's what we are doing.
Yeah,
that's great here. So I would like to move to our dear colleague, Dr. Nick Tapila.
Sure. Thanks, Amin. Can you enable my video here?
You must be able. I just asked. Oh, great. Yeah.
Okay. Perfect. So thank you everyone for participating and coming to this event. I didn't get a chance to introduce myself, so I'll do that very briefly. So I am Nick Tepelo, and my work sort of encompasses almost everything we've talked about today. I sort of work in the social aspects of advanced air mobility. My background in engineering, but it brings everything together with looking at first the physical, so the technology, is it ready? Is it safe? Looking then to the industry, what's going on with industry, whether it's the regulatory uncertainty or what impacts advanced air mobility is going to have. The environmental cases of greenhouse gas production, energy usage, and land use as well. Even equity, so the access and transportation deficit being a big thing that advanced air mobility can introduce, as well as design for accessibility, because we think about when we go to design and look at our design envelope, we're considering the average person, but there are, for example, in Canada, 22% of Canadians have a disability. And it's a staggering number to think about. But these are people who need access to the technology as well. And lastly is the legal side of things. So branching in privacy protection and data acquisition, how AI can infringe on people's privacy. So there's all these different aspects that we don't necessarily look at firsthand that I sort of try to bring together. And when we look at the presentations that were today, we had sort of elements in all of these different categories. So for example, Niels and Noah and Syed and Aziz talking about the physical systems, whether it was aerodynamics or advanced air mobility manufacturing. On the industry side, with the flight guidance and urban traffic management from Nabil and Chris. The environmental side, so just how these systems are fitting into society with presentations from Ottavio and Nihal on noise and vertiport design. On the equity as well, so Bree talking about medical drone delivery, and as well as Michaela talking about sort of expanding the typical envelope of how drones are used to sports and getting inclusivity from younger generations. And then lastly was the legal aspects, and that was Kayla's presentation on multi-stakeholder initiatives. So all of these come together into this wide encompassing area of focus. And that's good, because when we look at our inclusivity in our research council, we have about 18 people who are part of it, and we've come from all over the world. 45% from North America, 33% from Europe, and 22% from the Asia Pacific region. And background as well, we've got people from engineering to architecture, human factors, law, health sciences, transportation, and even general aviation. So branching all of these together allows us to tackle different research problems and sort of focus on the big picture. And that really falls into the aims of the AAM Institute, being safety, dignity, and security. So all of these aspects we're able to advocate for and work towards. I want to thank everyone who did come to present today and who talked about their various avenues of research, as well as our guest speakers, Lucas from DLR and Julia from Mary Cuval. And as well as all of the Research Council members who took the time to present today. And again, I want to thank our sponsor that came through at the very last minute. And that was Power Up America, which is an electric vehicle charging network, setting the standard for EVs and eVTOLs. Their goal is to provide customers with convenient and reliable charging network that is community-centered, and to build a robust infrastructure of charging stations to ensure wherever you are, you can charge with ease. And infrastructure is really the key to enabling the advanced air mobility globally. So with that, thank you very much. I guess we can sign off at this point. If you have any questions, you could come to me and I will pass them on to the right person. But again, thank you for your attendance and your time. Thanks to the people who stayed up late. I see Niels is still here. It's 1 a.m. in Australia right now. So thank you for staying up with us. And yeah, thank you again.
Thank you, everyone. Yes, thank you.
Okay, thank you. Bye-bye.
Thank you.
Great.
So I think if you just end the recording, because I think that's going on your side there.
Yes, I'm trying. I should just click on end the session. Okay. Uh-huh.